This is Precalc. It's 8-28, and it says the tiny town of Twin Poly Peaks is located next to a lake, both of which are in between two mountain peaks. The profile of the landscape can be modeled by this function, f of x equals negative 0.0005, anyway, by this function, where x is horizontal distance in miles, and f of x is miles above sea level. The lake is below sea level and the town is above sea level. Sketch the graph of the profile of the landscape. Use an appropriate domain. So this one, I started this in class. I started sketching it because I know that I can just sketch it by looking at these numbers. So, and this is what I ended up doing. I see that at -3, there's going to be a intercept, and at 1, oh, this is a -1, and this one will give me a 1, but it's a fifth root, so I know it's going to run along the axis a little bit, and then this is 4.5, so that's 1, 2, 3, 4, 5, so there's 1 here. Okay, so, and I know that it is, I think we said it had a degree of 8. It's got 5, 6, 7, 8. And it's got a negative sign in front of it. So we know it's going to go, it's going to have this kind of form. The endpoints are going to go down. So we know it has to come up through 4.5. So it'll come up, we don't know how high it's going to go. And then it's going to come and it's going to flatten out a little bit here because that's a fifth root. The higher I put this root, the more flat it's going to look. And it's eventually going to go below the axis. We don't know exactly where. Actually, I ended up just putting it on Desmos and then I could see. Anyway, it's going to sink below the axis and then it's got to come up somewhere. So it's going to come up here. And then it's going to come back down. We don't know how high these peaks are, really. You could put it in Desmos and you would know. Okay, so that's like a rough sketch. And it says, sketch the graph of the profile of the landscape. So if you just did it without Desmos, you might end up with something that looks like this. Here's what the book ended up with. It's very interesting. They show this little gap right here. When I put it on Desmos and I zoomed in, I could actually see that little gap too. So we're going to use that to answer some of the questions. So any sketch that looks kind of like this is okay, either by doing it the way I did it or doing it by Desmos. And then letter B says, if the width of the lake is captured in the profile of the landscape, approximately how wide is the lake? So this one was a little confusing. We found out that the lake is below sea level. So the only place on this graph, like if you just go by looks, there's only one place that's below sea level, and it's right here. And it goes from 0 to -1, so it's just 1. If you look at this graph, it's kind of hard to tell. If you look at Desmos, it also looks like it's 1. So we're just going to, if you don't mind, it's not very exact, but we're going to go with that. We're just going to say it's 1 mile. Because remember it said the x's are the horizontal distance in miles. And the y is the vertical, or it's the miles above sea level. Okay, so letter C says, approximately how wide is the town if there's nothing above 100 feet over sea level? Well, I was reading that wrong in class. These are in miles. 100 feet, a mile has 5,280 feet in it. So 100 feet, it means that the town is flat. It's on the flatlands. So just looking by the graph, you could say that the town could probably only be like in between 1 and -1 if you look at this graph. And if you look at a Desmos graph, you'll see the same. So I don't have an easy way to show the Desmos on here. don't know how to do the split screen for you, but or I guess I could get it on my phone, but I don't have it on there. So if you look at the graph, the town, these were in miles. So 100 feet's like nothing. It's like super flat. So the how wide is the town? 2 miles. It's just going to be 2 miles because it's in between the two peaks. And that's all I got.